On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at another example of logarithmic differentiation, and this example here is similar to video number 1, except now, notice in video number 1 we have y equals x to the sine of x plus 2 power. All of this stuff was in the exponent. Now we simply have the sine of x in the exponent, and we are adding 2 after that. So we're still going to do logarithmic differentiation because we have some function of x raised to some function of x as a power. So we have something with an x raised to something with an x power, a good indicator that you want to use logarithmic differentiation. So we want to find the derivative here, and before I do that, since I know I want to use logarithmic differentiation to take care of this, I'm going to move that 2 over here to this side. So we have y minus 2, we're just subtracting 2 from both sides, equals x to the sine of x power. Now back in video 1, we did not do this because we had sine of x plus 2. All of that was in our exponent. So we went and took the natural log of both sides and then proceeded on, doing the product rule and stuff like that. Well, we're going to do that now. We're going to go ahead and take the natural log of both sides. Natural log of y minus 2 is equal to the natural log of x to the sine of x power. And now that we have this, what we can do next is we can apply that power rule just like we did back in video 1. So natural log of y minus 2 is equal to, and we pull the power down, pull the sine of x down, so we have sine of x, natural log of x. That's the power rule that we can apply based off of our properties of logarithms. Now, we're ready to differentiate. We're going to differentiate this side here. The derivative of natural log of y minus 2 is going to be 1 over y minus 2. So 1 over y minus 2, but we have to tack on that y prime because we are differentiating with respect to x. So remember, implicit differentiation, whenever you differentiate something that doesn't have an x in it, in this case it's got a y in it, tack on that y prime, is equal to. Now we want to do the product rule here. Let's call the sine of x f, let's call the natural log of x g. So let's do the product rule. F prime times g, well, the derivative of sine, f prime is going to be cosine of x times g, that's the natural log of x, plus, finishing the product rule, g prime times f. The derivative of g, the derivative of natural log, is 1 over x times f. This is where we leave the sine of x alone. And from here, it works very similar to all of the other logarithmic differentiation problems. What I would do here is I would multiply this side by y minus 2 to get rid of the y minus 2 over here because we are technically dividing by that. And just make sure you multiply by y minus 2 on this side as well. The y minus 2's cancel out. We have y prime is equal to. Now, this y minus 2, we can go back and look to see what y was originally equal to, and we can plug this x to the sine of x plus 2. Since that's equal to y, we can plug that back in to this spot down here, right there. So cleaning this up, we have cosine of x times the natural log of x plus sine of x over x. And again, all I'm doing there is just multiplying these two things together. And then we multiply this by y minus 2. But remember, y is equal to x to the sine of x power plus 2. Remember, that's what y was equal to. And then we got to come back and subtract 2. So that will get rid of these two pieces here at least. And if you wanted to distribute, that'll be just fine. But I'm just going to leave my answer like this. X to the sine of x, I'll write that down first, times this stuff that we have here. And just like that, that is going to be our derivative. Not a lot of simplifying we can do here. Again, this is just exercising your ability to take derivatives and mainly recognizing that logarithmic differentiation is going to be your best plan of attack here because you have some function of x raised to some function of x power. The difference here between this entire problem and the one we did back here, over here, video 1, we had this plus 2 up in the exponent. So we immediately took the natural log of both sides, whereas here we had to do one initial step by moving the 2 over by subtracting, and then proceeding forward by taking the natural log of both sides, and then finding the derivative using implicit differentiation. And as you can see here, these two answers are different, but then again, they have some similarities. What you'll notice here is we have a +2 and a +2. We're missing the +2 over here on this one. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.